In the 21st century, architecture is undergoing a radical transformation. The future of living is no longer defined by static buildings made of steel and concrete, but by structures that breathe, adapt, and evolve with their environment. This emerging discipline, known as bio-integrated architecture, represents the seamless fusion of biology, technology, and design, redefining what it means to inhabit a space. At its core, bio-integrated architecture seeks harmony between humans and the natural world. Traditional urban development often isolates people from nature, creating concrete jungles that consume vast amounts of energy and resources. In contrast, bio-integrated buildings are living ecosystems designed to coexist with their surroundings rather than dominate them. They utilize natural processes for energy, water, and waste management, while incorporating organic materials that grow, regenerate, or even heal themselves. Imagine a skyscraper whose walls are made of algae panels that capture carbon dioxide and produce oxygen. These panels not only clean the air but also generate biofuel, transforming pollution into a renewable resource. Picture a home with living roofs that cultivate edible plants, or walls embedded with microorganisms that filter air and regulate humidity. These aren't futuristic fantasies, they are real-world innovations already being tested by architects, scientists, and environmental engineers around the globe. One of the key pillars of bio-integrated design is biomimicry, the practice of emulating nature's time-tested patterns and strategies. Nature is the ultimate designer, efficient, adaptive, and sustainable. By studying organisms and ecosystems, architects learn how to create buildings that function like living beings. The lotus leaf, for example, has inspired self-cleaning building materials, termite mounds, with their intricate ventilation systems, have influenced natural cooling designs for skyscrapers in hot climates. The honeycomb structure of bees has led to stronger and lighter construction materials. Beyond design inspiration, living materials are becoming the foundation of this architectural revolution. Scientists have developed biobricks made from bacteria that produce calcium carbonate, a key ingredient in limestone. These bricks are grown rather than manufactured, requiring minimal energy and emitting almost no carbon dioxide. Other materials, such as mycelium, the root network of fungi, can be molded into insulation panels that are lightweight, fire-resistant, and biodegradable. These organic components can even repair themselves when damaged, mirroring how living tissue heals over time. Smart technology plays an equally critical role in this evolution. Sensors embedded within bioarchitectural structures monitor air quality, temperature, light levels, and moisture enrichment. This data allows the building to adapt dynamically, opening vents for natural airflow, adjusting light exposure to encourage plant growth, or redistributing water to maintain hydration in green walls. Essentially, these buildings act like organisms with a nervous system, intelligent, responsive, and self-regulating. One of the most promising aspects of bio-integrated architecture lies in urban regeneration. Cities worldwide are facing growing challenges: pollution, overcrowding, and the heat island effect. Bioarchitectural designs can revitalize urban spaces by integrating vegetation into the built environment. Vertical forests, green facades, and rooftop farms not only improve air quality but also restore biodiversity. They provide habitats for birds and insects, turning sterile cities into thriving ecosystems. This blend of greenery and infrastructure enhances mental well-being, reduces stress, and reconnects humans with the rhythms of nature. In future cities, buildings could become active participants in the planet's ecological cycle. Rainwater would be collected and purified naturally. Organic waste could feed microbial systems that generate biogas for energy. The structure's skin might photosynthesize, converting sunlight into fuel. Walls could even change color or transparency based on environmental conditions, optimizing comfort while reducing energy use. Each building, therefore, would act as a living cell within the greater organism of the city. However, this vision also poses challenges. The integration of living systems into architecture requires interdisciplinary collaboration between architects, biologists, engineers, and data scientists. Maintenance becomes more complex as living components require care and balance. Ethical and regulatory questions arise. Who is responsible for a living building's health? How do we control or limit biological growth within urban environments? Despite these concerns, the potential benefits far outweigh the difficulties. The ultimate goal of bio-integrated architecture is to transition from sustainability to regeneration. While sustainable design seeks to reduce harm, regenerative design aspires to heal and improve the environment. A truly bio-integrated city would not just minimize its footprint, it would actively clean the air, restore soil, and generate resources. In such a world, humans wouldn't just live on Earth, they would live with Earth as part of an interconnected biological network. As we look ahead, this architectural philosophy invites us to rethink our relationship with our buildings will no longer be lifeless shelters, but extensions of nature, vibrant, breathing entities that nurture both the planet and its inhabitants. In the near future, our homes may pulse with life, our cities may bloom like forests, and architecture itself may become a living art form. Bio-integrated architecture is not merely the future of construction, it is the rebirth of our bond with the natural world. By designing with life, we rediscover what it truly means to live.